My presentations will be about what we've done so far in Islandora in the field of in storing the data in the field of the arts and humanities. Uh, since I'm not very sure if everybody here is familiar with Islandora, my presentation will be split into two parts. The first part will be just a short introduction what Islandora is and how we use it. And then I will go for the second part of my presentation, and I'll show you what we've done so far in Islandora. So, uh, just a quick overview. Islandora is just a system for storing and providing digital data. It's just simple. And a few words on Islandora architecture. Islandora is, let's say, set of modules or components, and the main components, there are two or three, depends on your point of view. The main component, or the which acts as a front end, is Drupal. The the most important thing you can do in Drupal is a data modeling, and it serves also as a metadata storage. The second most important component is Fedora, which acts as a backend and is used for data storage and also for the metadata storage. Behind this, there's also a Solar search engine that's obvious that it serves for users in UI to search metadata and data, and so on. There's few other components. It's not so important. From the software developer point of view, Islandora is some kind of pre-configured Drupal connected to Fedora via the Drupal's file system connector, which is a general connector you can use for connect different backends to Drupal. What is the relationship between Islandora and Fedora? Islandora itself is shipped with something that is called repository item, which is a digital object or a digital object class with predefined metadata fields, those that you can expect: title, object type, author, identifier, etc., etc., and which can be associated, the repository item can be associated with files or the data, if you want to call it this way. Files and repository items is stored in Fedora by default. And also the repository item metadata are mapped to Fedora, which means the metadata is stored both in Drupal and Fedora. And we can call it synchronization or so, but it's just one way from Drupal to Fedora. And this mapping of the repository items metadata to Fedora is a part of Islandora installation. So the community prepares those mapping. So this is how it works. There's few words why Islandora Drupal and why we have chosen this. Well, it's great because the repository item is ready. You have it just out of the box and everything works if you are happy with it. But if it doesn't fit to you, it is easy to easily create your own repository items with different metadata fields and different views on those metadata, and it's perfectly fine to do this with some consequences. Everything can be done via UI in Drupal or externally in YAML and then imported to Drupal. It's just easy to do it. Once some of your own data model or your digital object is created, Drupal prepares forms for end users to use it, just to insert new objects. There's revisions, default views, etc., etc. So this is some advantages that Drupal has. Those customizations, if you don't want to use the default Islandora repository item, has some consequences that affects the connection to Fedora. The data files itself are not affected and go to Fedora as usual. That's fine. But once you don't use repository item, your mappings to Fedora for metadata is lost. And you have to create your own, which sometimes can be not an easy task because our data objects or data types are very complex. However, it's still good to use Fedora because it's good to use it for long-term preservation and for RDF because there is OCFL and well, it's good to use it. So that's for the Fedora and Islandora connection part. And let's move to what we do and what we have done in Islandora in the fields of arts and humanities. We are a small team that works at Masaryk University, which is the second biggest university in the Czech Republic in the middle of the Europe. It's located in the second largest city in Czech Republic as well. The first one is capital Prague. We're still competing with them. We have set up a research infrastructure, which is called Digitalia Arts. And this infrastructure is set up at the Faculty of Arts just to serve the researchers at the Faculty of Arts. The aim is to store, preserve, publish, enrich, process, and reuse research data at the faculty. We are also a member of the national project and national infrastructure called Lindat Kvariach, and we are now also a member of European Open Science Cloud. The motivations and goals. The motivation is simple because in the past, a lot of researchers handle their data in a very inappropriate way. They have stored, because it's still happening, their data at flash disks, their local disks. Nobody knows where the data really are. They are not backed up and so on. Or this is something that we don't want to. So our goal is to provide for the researchers at faculty a sustainable and unified environment where they can store their research data, and not only to store, but we would like to provide them some kind of virtual research environment just to help them or to allow them to work with their data and to share them somehow, which is not an easy task. This is a short overview of our team. As you can see, there are 2.5 data curators and 3.5 developers. It's not a mistake. The young lady who is in between, she is very capable because she can do data curators work, and she is very capable software developer as well. So this is not a mistake. What we would like to store, because the research at faculty is very heterogeneous. There are a lot of types of data to store. Traditionally, publications, which is easy, is journals, monographs, proceedings, and so. But there are archaeological artifacts, linguistics data, maps and history-related materials, textile patterns, encyclopedia, archival materials, and various types of data to store and to present to the end users. Uh, this is just a very short overview of Islandora platforms we have already created or which are which are to be in production soon. I will tell about them in more detail a little bit later. And this is just a quick overview of a workflow. At the very beginning, we have a discussion with a researcher, what she or he needs. And then we do data modeling, data migration if necessary, interface creation, user testing, publish presentation, and if the platform is in production, there's a maintenance step. It looks simple, but it's a quite complicated process, involves a lot of stuff and a lot of people at faculty. How we use Islandora. As I've already mentioned, Islandora is shipped with a default repository item, but this is too simple for us, so we do our own data modeling. We create our own data models in the terminology of Drupal, our own content types, which are often very complex depending on the Islandora platform or depending on the type of the data we want to store in Islandora. The general rule is to write as little custom code as possible, because it's always very expensive to write our custom code. If it's possible to configure it, let's configure it. It's not always possible. We have quite few or a lot, depends, custom modules for Drupal, but still this is the general rule we try to follow. Everything is shared or versioned on GitHub. It's not very well documented yet, but I think, I'm not sure if it will be much better in the future, because developers don't want to write documentation, but it's open and everybody can download it and reuse it. We also use Dublin Core and OAI PMH to expose metadata and links to data to anyone who would like to reuse it. And we also assign handles, I mean handles.net, as a persistent identifiers. And we plan to also assign DOIs provided by the data site. This is in progress right now, and we are working on it. But we probably move to DOIs, from handles to DOIs in the future. Just a few notes on technical background. Proxmox as a virtualization platform, everything is on Ubuntu 22 and everything is Ansible driven. Future plans, we would like to migrate to Isle, it means Islandora Enterprise, it's a Dockerized Islandora, and to have everything in our Kubernetes. And we would like to also connect our Fedora storage to European Open Science Cloud S3 storage. This is this is also in the process right now. So let's take a look on what we've already done or what we've already created. Our biggest Islandora instance is the digital library of the Faculty of Arts. There are mostly publications stored, and it covers everything that has ever been published by the faculty. There's journals, proceedings, monographs. It's over 36,000 digital objects. We have also integration with our university open journal system, so the metadata can go back and forth between those systems and can be shared. We have also implemented a kind of citation generator, which can provide you a citation for the stored articles and publications in different citation styles. Just for example, this is the landing page for a single journal. As you can see, there's some metadata, list of the volumes and issues. There's nothing special. If you click on an article, you can see also the metadata about the article, like ISSN, DOI, and so link to PDF. Below the PDF, you can see our citation generator. Also, nothing really special. What we've done as an authority management, which means that a lot of authors published in the journals or monographs under the different versions of their names. It means different spelling, transliteration, married name, etc. So we have implemented in Drupal a system for managing those authority names. So if you want to see all articles by one author, our Islandora can list you all the articles, no matter what version or what spelling of the name of the author is. So the platform which will be available probably at the end of this year is called Rapcore, which is a French language corpus of spoken French in rap songs. There's mostly audio and image files. Audio means the songs, and image files means the covers of the CDs. And there's a lot of working with text in multi-step workflows. This platform allows researchers to fill in the data, to work with them somehow. For example, we implemented customized edit forms where the researcher can see the scan of the text of the song, then beside this scan there is an OCR of this text, so they can annotate the text and they can also play the song just to listen to it and make corrections between the text, what the interpret sings and what is written on the coverage of the CD. So another example is a platform which is called Cinematic Brno. It covers the history of cinemas in Brno, and the content is scanned programs, what movies have been performed when, and there are scans of ads, posters, there are interviews with cinema visitors, etc., etc. This platform includes interactive map, where you can just use a slider and choose a different year and see which cinema were located was located where in the city of Brno. Another example of a different kind of platform is platform that is called beauty patterns. There are stored patterns of medieval and post-medieval textiles. It is mostly high-res images, and for example, we implemented a comparison feature which looks like this way. If a researcher wants to compare two or three or more textiles, she or he can just put it into a set, and it is visualized the way you can see on the slide. And there's a lot of metadata, and you can easily compare how do they differ. Another example of our platform is Projectiles, which is an archaeological platform and there are archaeological artifact stores, mostly arrowheads and wrist guards. It's images and 3D models stored. There's special kind of browse used by the archaeologists. They can browse it by the culture, by the site, by the grave. There are rich facets and also rich metadata because they do a lot of chemical and physical analysis, and they need to store everything there. For example, this is how it looks like. As you can see, you can browse the graves and features. There are some facets, so you can narrow it just choosing a specific culture or specific site. So this is an example how it looks like. As you can see, this is an arrowhead. There are a lot of metadata, and you can download a 3D model of the arrowhead and also the high-res images that is stored in Islandora. Another example is that we try to build up a more general platform for archaeologists, because all archaeologists use almost the same data model. I mean the very similar metadata. So our idea was to create a more general platform and just to split those different types of archaeological artifacts into, we call it, sub-platforms. So this is an example of general platform and three sub-platforms of archaeological data. We have found this a bit complicated. It works, but we will not probably go this way in the future. This is just an example how it looks like. The general platform archaeodata somehow aggregates everything that is stored in sub-platforms. We have also integrated 3D model preview on one of those sub-platforms. It's just a simple JavaScript library we plan to use a library that is called 3D Hop to do this, because this 3D Hop probably can provide us annotations for those stored models, which is a feature that our researchers want to have. Maybe I guess this is the last example of our Islandora platform. It's called Herbaria Manuscripta. It's a database of herbals found in medieval manuscripts. There's almost no data. It's just a metadata platform. And this is how it looks like. The research is about what kind of medicaments is included in a certain herbal and so on. This is just another example of what can be done in Islandora. So our future plan, which is closely related to Fedora, is that we want to use Islandora just to set up some kind of semantic interoperability. We would like to create a mapping from Drupal to Fedora to CDOC CRM ontology, which is widely used. And then we will be able to use a Blaze graph. So we would like to use RDF. It is also part of the Islandora installation. And we would like to use Fedora and OCFL as a kind of LTP, long-term preservation system in the future. So that's all from me. And if you have questions, one of our developers is also here, so we can also answer technical questions too.
That's great. Thank you so much. That was a great walkthrough. We really appreciate that. We look forward to continuing following along with your work there.
Thanks.
Thank you.